So now let's start to apply some of this knowledge. We want to find all the maximums and minimums and the intervals of increase and decrease for f at x equals x cubed minus 3x plus 1. So since we're looking for those intervals of increase and decrease and max and mins, we were just talking about how that all comes down to first derivative. And quite honestly, since I named this the first derivative test, the pretty obvious first step is going to be we're going to take the first derivative of this. So I get f prime at x equals 3x squared minus 3. Okay, so now that we've got the f prime at x, well, we want to find the intervals of increase and decrease. So to do that, the first thing that I'm going to do is I'm going to establish where the zeros of this function are, or where the zeros of my derivative function are. By finding the zeros, I find the spots that indicate where I can switch from increasing to decreasing. Because to go from increasing and decreasing, we need to go through a zero first. So I factor this, and I get f prime at x equals 3x squared minus 1, or it will equal 3x minus 1, x plus 1. So those zeros, or we're looking for where this equals to 0, it's going to equal 0 when x equals plus or minus 1. Now, for future reference, we are going to call these critical points, but we'll talk a bit more about that naming once we've done second derivative and once we get more into the whole idea of curve sketching. So now we know that it's 0 when x equals plus or minus 1. From there, what I'm going to do is I'm going to use this chart method. And the chart method is a very, very common way of looking at these things, and it will become very, very valuable to us when we get to the curve sketching part of this. First thing that I'm going to do is I'm going to create my intervals. So if plus or minus 1 are the places where I can change, that means that my intervals will be negative infinity to negative 1, negative 1 to 1, and 1 to infinity. Now you'll notice that I'm using open brackets. The reason why I'm using open brackets is because we don't want to include the endpoints in this. If I include the endpoints in this, well, it would equal 0. From there, up top, I'm going to write out the factors that I have. So I have 3, and then I'm going to go x minus 1, and then I'm going to write out my x plus 1 factor, and then we're going to have our f prime at x. Now, I know it may seem a bit weird what I'm writing out here, but if you just follow with me, it'll hopefully make sense. The next piece of this is we're looking for the intervals of increase or decrease. So my increase was when f prime at x was positive or greater than 0, and my decrease is when f prime at x is negative or when my f prime at x is less than 0. Next, we have these intervals right here. Why do we have these intervals? Because the only place where I can switch from positive to negative is at plus or minus 1, also known as the critical points. So anything before negative 1, it would either have to all be positive or negative, or it would all be increasing or decreasing, and so on and so forth for my other intervals. So what I'm going to do is I'm going to test the positivity or the negativity of this. How? Well, from negative infinity to negative 1, let's pick a number. I don't know, say negative 2. So 3 times negative 2 minus 1, well, that's going to end up giving us a negative value. So I'm going to write a negative sign right there. Negative 2 plus 1 gives me a negative value. So that means that my two factors, or my two parts of the equation, are each negative. In the equation, they get multiplied together, and we know that a negative times a negative equals a positive. So that simply means that we're going to be increasing. I do the same thing from negative 1 to 1. We pick a number in between them, say 0. 0 is negative here. If I put 0 into there, it'll be positive. And a positive times a negative is a negative. So that means that I'm going to be decreasing in that case. Looking at my next one, I pick a number between 1 and infinity, say 5. there it'll be positive, there it'll be positive. So that will give me a positive. So in this case, it will be increasing. So my intervals of increase and decrease, well, that's pretty obvious at this point. My increase is going to be from negative infinity to negative 1, or subsequently it's going to be from 1 to infinity. Now, sometimes you may see this written in set notation, and what they're going to use in between right there is a big U that is the union symbol. It basically just means or, but for my purposes, either one of these would be completely fine. Then my intervals of decrease is just going to be from negative 1 to 1. Now we haven't completely answered this question. I'm still missing where I want to find all the maximums and the minimums. So if we look at this right here, we get that our function is increasing, then decreasing, then increasing. Now, this is not necessarily what the function looks like. I'm just drawing this out to show sort of what's going on. When I go from the increasing to the decreasing, well, what happens there? That gives us a maximum. And when I go from decreasing to increasing, we get a minimum there. So this means that I have a maximum at x equals negative 1, and I have a minimum at x equals 1. I hope you guys have enjoyed. We'll get to the next lesson in a bit.